A specific moment when evaluating the way the solid element of the building behaves as part of passive solar system is the thing called thermal bridge. Thermal bridges are parts of the solid elements that, for different reasons, allow bigger amount of heat to transfer through them to the outer um, environment. The thermal bridges can be material thermal bridges when the material is the same but we have an, an edge changing of the direction the element goes, and in that place a single measure unit of the inner surface has much more outer surface that radiates the heat, and that's why in the edges of the buildings the heat loss is more than on the other parts of the elements. The second thermal bridges are by material when there are parts in the element that are with different material, and this different material allows much more to transfer through it. And the picture on the previous slide was an infrared picture of material thermal bridges in a wall solid element of the building. The third kind of thermal bridge is structural thermal bridge, when an element goes outside with some of its surface, such are balconies or parts of the walls that separate balconies between the neighbors, or when for some design reason building is designed in sectors, and the different sectors are not in the same row but go in front of the other sector or a little behind it, and there are again walls that face on in some of their parts face the outer air, and the next part goes inside the rooms. There is also a thermal bridge which is called periodically appearing, and is similar to columns in walls. The next group are the convective thermal bridges, and they are where we have gaps between different elements, let's say between the walls and the cases of the windows, or the cases of the windows and the wing of the window that is opening and closes, and where air can pass and moves. In the thinner the gap is, the higher the speed of the movement of the air is, and that is why these convective thermal bridges are very dangerous. And the last group are thermal bridges that depend on the surrounding elements. For reason, if for example, sorry, if a building is detached to another building, so the wall in this part behaves in one way, and in this in other, and um, this additional volume here has some influence upon some impact upon the thermal behavior of that wall element. So thermal bridges need additional care, some additional measures to prevent the heat loss, and the inner insulation is not that good decision because still the heat loss is going at its full extent. The outer insulation has some effect positive, still not doesn't prevent the whole heat loss through thermal bridge. Also, if the outer wall is with more isolating material, still there is some heat loss. And actually, the proper uh, decision for material thermal bridges is that they do not reach the outer surface of the wall element. This can be a structural wall uh, or a plate, a floor plate. It stops about 5 to 10 centimeters before the outer surface, and there is a space where additional insulation is put, and after that the next layer going in front of all the element is put. And what is important to be remember is that this additional insulation in front of the thermal bridge should not cover only its forehead, but it should be twice longer than the forehead of the thermal bridge element. And if the thermal bridge is structural one, the element goes outside, which are most often balconies. Not the only solution, proper solution is all the outer part of the element to be covered with insulation, which of course is very expensive and not much people accept that kind of solution, but that is the only one since neither inner insulation, outer insulation, or uh, wall element with different material helps to prevent the heat loss. The other part is that the outer um, the other moment is that the outer part of the structural bridge cools very strongly in the outside, and that cold doesn't stop to at the wall. It goes inside the room for sometimes up to 2.5 meters in depth, thus making the floor cold next to the outer to the facade walls, and also causes condense and the health ruining processes following the condense process. And this is an infrared thermal picture of structural mm, thermal bridge, a balcony, and all the amount of heat it radiates to the outer colder environment, while as the walls that are insulated almost do not um, radiate. And here also some convective thermal bridge can be seen on that infrared picture, but the balcony is definitely um, large enough surface with enough amount of energy taken from inside and thrown away to the outside. So again, the only decision for such for structural thermal bridges is all this surface to be covered with some layer of effective insulation.